Hi friends, good morning. This is Captain Deepak here once again. It's a bright Saturday morning in Singapore and I've just cleared my office emails when I thought I should complete this video which I started yesterday. Tomorrow is going to be a big day. Tomorrow is the India-Australia World Cup final. I hope this is going to be India's third. Come on, chuck the India. Okay, now back to business. Let's do some stability. So what am I trying to do in this video or trying to explain in this video? We're going to look at calculation of hydrostatic draft from drafts forward and aft. Okay, so let's get going. Now, what is hydrostatic draft? I think I explained this before also, but just as a recap, the hydrostatic draft is your draft at the center of flotation, COF. What is COF? I hope all of you remember the seesaw theory. COF, or the center of flotation, is the pivot point. It's the point about which the ship pivots or rotates about. Quite similar to the point P which I had shown in my previous video with regard to the seesaw. Okay, I think now this is clear. Hydrostatic draft, it is the draft at the center of flotation. Let's move on. Now, the question given to us is we need to find out hydrostatic draft from the aft draft. If you go through the formulas, this is how it comes. Hydrostatic draft equal to aft draft plus or minus the correction. What is the correction? Correction is equal to trim into LCF. LCF is the distance of the center of flotation from your aft perpendicular. So correction is equal to trim into LCF divided by LBP, which is your length between perpendiculars. The correction is negative when trimmed by stern and the correction is positive when trimmed by head. Quite simple, right? Yeah, but I don't really want you people to mug up this thing, mug up these formulas. Mugging up is you will mug it up and then you will forget it the next day. The intention of this video is to actually try and teach or try and explain you how did we actually end up with this formula. And once you sort of understand that, I think you will not forget this formula. Okay, so let's take a look at how did we in the first place arrive at this formula. I wanted to draw a ship shape, but that was too difficult. So I put in some sort of animations to make it as clear as possible. No, I'm still learning PowerPoint, but yeah, let's see. Okay, now you have a ship and you have it at a water line. So that red line is your water line, which we represent by WL. Now you have 2 points. Let's name one of the points as H, which is the midship point. And let's put another point, which is F, which is your center of flotation. Now remember, center of flotation is the point about which the ship pivots. And hydrostatic draft is the draft at the center of flotation. Okay, going ahead, draw a line through the midships. Let's put our aft perpendicular and then let's put our forward perpendicular. And what's the distance between the aft perpendicular and the forward perpendicular? That's your LBP. So that green line is actually representing your keel. And the distance between your aft perpendicular and forward perpendicular is your length between perpendiculars. Now let's say we load some cargo forward of the center of flotation. Now if you have gone through my previous videos, if you're going to load something forward of the center of flotation, of course it's going to trim by head. If you load it aft of the center of flotation, it is going to trim by stern. It's quite simple, right? Now imagine we have loaded something forward of the center of flotation. How do you think the water line is going to look like? Obviously, your forward draft is going to increase and your aft draft is going to decrease. So we have loaded something forward of the center of flotation, and hence your water line is going to look like this red line which has just appeared on your screen, which we will name as W1 L1. Okay, forward draft has increased, right? That's why the distance from L1 to the green line, which is your keel, has increased, and your trim and your aft draft has reduced. That's why the distance from W1 to that green line has reduced. Okay, so this is our new water line W1 L1. Now what? Now the arrow that I just placed, that is the difference in draft, difference in the initial draft, and difference from the initial and final forward draft. So we name that as Y. Similarly, the difference between the original aft draft and the new aft draft, we name it as Z. And now we have Z and Y. So what is Z plus Y? Z plus Y is in fact your change in total trim, right? So your trim actually is Z plus Y, correct? Okay. Now moving on. Okay, this blue line, that is what I said is Z plus Y, which is in fact your total trim. We put one more blue line, which is in fact your LBP, length between perpendiculars. Now, if you look at this angle, sorry, if you look at this angle and if you look at this angle, both these angles are same because if you go back to your class 8, class 10 parallel lines theories, these are corresponding angles. So both these angles are same. And if you go to this angle, now this is also same because these are vertically opposite angles. Again, theory from our school days. So you have this theta angle, which is actually same. You have these three angles, which is actually same. What is our intention? Our intention is to find out the hydrostatic draft. And I had said this earlier, hydrostatic draft is your draft at the center of flotation. So that is being symbolized by that dotted arrow there, dotted line there. Moving on, I complete this triangle now, the blue triangle. Okay, and I also complete this yellow triangle. And now it's time to actually go back to our school trigonometry. Now, if you look at the blue triangle, okay, and if we have to say what is tan theta, okay, now tan theta is z plus y, right? If you look at that blue triangle, the side, opposite side is z plus y, which is your total trim, divided by the adjacent side, and the adjacent side is your LBP. So tan theta is equal to trim by LBP. Now take a look at the yellow triangle. Now yellow triangle, oh, I had Alexa speak up in between. Okay, uh, look at the yellow triangle, and the yellow triangle tan theta is equal to Z divided by WF, which in essence means that tan theta equal to Z divided by WF, which is the LCF. Now I've said Z is the correction here. Why have I said Z is the correction here? Because from the aft draft, which is W1 to that green line, if we apply Z, then we will get the hydrostatic draft, which is from F to the green line. Okay, so tan theta is equal to Z, which is the correction, divided by WF, which is actually your LCF. And if you now equate these two, because tan theta is same, and if you equate trim by LBP equal to correction by LCF, what do we get? Oh, wow. So I have some bouncing animations here. So we get Z, which is the correction, is equal to LCF into trim divided by LBP. And this is exactly what I told in one or two slides before. But here now I've explained to you how exactly you've got this. So correction equal to LCF into trim by LBP. Now, if you go about doing it in a similar manner, we can also find that the hydrostatic draft is equal to the mean draft plus or minus correction. And in this case, correction is equal to HF. HF is the distance of the midships from the center of flotation. So HF into trim divided by LBP. The correction is positive when the COF is abaft midships, H, which means the ship is trimmed by stern, and it is negative when the COF is forward of the midships, which means the ship is trimmed by head. I think, or I hope, I have been able to explain this concept clearly. The intention, I don't want people to mug up formulas. It's really important that we understand how these formulas, how did we arrive at these formulas? And once we know that, then it becomes sort of easy for us. So, yeah, so I've come to the end of part one of this video, wherein I have explained how did we actually come to this formula of correction and how what is the relationship between aft draft and midship draft. In part two of the video, I'll take up an actual example from Hindship, which will be question 10. That I'll do after the India-Australia final. In any case, let me know if you have any doubts or suggestions for improvement. I'm definitely going to buy a mic when I get back to India for my leave in December. But till then, this is Captain Deepak and Captain Jibin signing off. Take care. Hope India wins. Chak de India. Thank you. Take care.